Alright, so now I want to look at how to do exploratory data analysis. The previous steps were just to prepare our data for data analysis, right? So this is the step that involves exploratory data analysis. EDA is basically one of the techniques that is often used in analyzing data set to summarize their main characteristics, often with visual methods, right? But you have to know that EDA basically have two techniques. We have data summarization and we have data visualization. So I want to start with the first one, which is data summary or data um, summarization, right? We'll be looking at data visualization very soon. So to begin with, we want to still make use of the final data, right? If you want to make use of the sample that you can go ahead and just change this to some that, but I want us to just look or make use of the final data. So I want to find the summary statistics for quantitative variables in this phrase. I want to look at some summary statistics for quantitative variables. So for our final data, you realize that if you go back, the first four columns are made up of quantitative variables, which are all in centimeters. So the specification here means we want to look at all rows for the first four columns, right? We want to get the summary statistics for these variables. So let's quickly run this. So once we run this, what do we see? So here we go. We have the summary statistics being displayed in the console. So we have separated length. The minimum value is around 4, right? We have the first quartile, we have the median value, the mean value, third quartile, maximum value. The same applies for the other variables, right? So once we are done with this, what can we do again? We can basically look for other quantitative measures like standard deviation or variance or quantiles by making use of the apply function. This function is basically useful anytime you have a data frame, right? Is basically useful for working with data frames, right? So this our data frame, that's our final data, right? And we want to pick the first four columns. So the first input is basically an argument for your data set, and the second input in here, the two is basically going to be for the columns. One is for rows. Once you change this argument to one, it means that you want to work with the rows, but once you have make it two, it means that you want to work with the columns, right? You want to work with these columns. Want to compute the measure for these columns, right? So that's why we have two there. And the next argument is for the function. So here I want to find the standard deviation, right? If you want to look for variance, you can just change this to var. Maybe if you want to find the mean, you can just change this one to mean or median, right? Just have to type median. But in here, I just want to work with standard deviation. So the function here is standard deviation. So let's quickly run this. So here we go. So I think it have to show in our console. Yep. Let me rerun it again. It's taking time to show. Okay, I think it's taking some time to show in the console. So once we run this, we will have the value being displayed in our console. I don't know why it's taking some time to show. Okay, let's wait for some. Let's wait for a while. I think. Yep. So here we go. So the separator length. These are the standard deviation that we have. So you can change the function if you want to look for the quantitative measure, right? So let's say you want to find a quantile, right? So I have to just change this function to be the same thing, but I'm just changing this function to quantile. So once we run this, so we have the quantiles for all the variables, right? The 25th percentile is the same as the first quartile, the 50th percentile is the same as the median, the 75th percentile is same as the third quartile, right? And we have it for all the other variables, right? So sometimes working with these original variables may not be good for some algorithm or some of the statistical methods that you'll be dealing with. So sometimes it is very important to transform your variables so that they can be on the same scale of measurement, right? So the next step is to basically look at data preprocessing or transformation by standardization and normalization. As I've already mentioned, that sometimes your original data set may be the variables may be they may be in different units of measurement, right? Fortunately for us, for this, they are all in centimeters. Sometimes this may be in a different unit, this may be in meters, this may be in kilogram, this may be in different units of measurement, which may not be helpful with some algorithm, right? Or some kind of statistical method that you want to use. It is very necessary to transform or pre-process these variables so that they can be on the same scale of measurement. And we normally do this by making use of standardization or by normalizing our data, right? The main difference between standardization and normalization is that with standardization, the variables will always have a mean of 0 and a standard deviation of 1, right? That's something that you have to sorry, that's something that you have to note, that with standardization we are going to basically we are looking at how the number of standard deviation that each data point is going to be away from the mean, right? Or the mean value. Whilst with normalization, it will always have a range of value between 0 and 1, right? It will scale it in such a way that whatever variables will be in a range of 0 and 1, right? So let me show you this. So this is basically the formula for standardizing a variable, and this is a formula for normalizing a variable. So with standardization, we are going to basically compute the standard deviation and the mean. We subtract each data point, right, from the mean, right? Then we divide by the standard deviation to get our standardized value. With normalization, we are going to basically um, subtract the minimum value from our data point and divide it by the range of the variable, right? So let's quickly continue with what we are doing. So in R, we can make use of, we can do this standardization or normalization by making use of this package, that's a caret package. So let's quickly run this. If you don't have this installed, then you have to install it by going to packages and go to install and type the name of caret to install, right? Or basically you can just use install dot packages, right, just to install this caret. So I've already done this, so I'm just going to comment it, right? So once we load this library, we can calculate the pre-processed parameters from our data set. So using the caret library, we are going to make use of this function, the pre-process function, just to get us the pre-processed parameters for standardization, normalization. So I'm going to, this is basically for, let me separate it. Let me separate this. So let me separate, yeah. So this is basically for standardization, right? So we want to pre-process our um, variables. So for finding that, we are picking the first four columns, which are quantitative, and the method that we are using is centering and scaling. The center transform basically will calculate the mean for a variable and subtract it from each of the data points, right? And the scaling or the scale transform will basically calculate the standard deviation for a variable and divide each of the each of the data point by that standard deviation. So this basically gives us standardization, right? As I've already shown in the slides. So let's run this. Let me do it. Yep. Now let me run. So I'm assigning everything to path.std to get me the parameter for that pre-process variables. So for the normalization, we are using range because that's basically what it makes use of, right? So let's run this. Alright, so once we are done with this, we can now um, look at the transform um, data set by standardization by making use of the predict function. So I want to assign my standardized data to std.dat. So by making use of the predict function I'm going to basically and also adopting these parameter standardization values, I'm going to get my transform data set. So let's run this. Right, and let's do the same for the normalized data. Right, so in here I'm using the path.norm, that's the parameter values that I calculated. Right, so that's basically what I'm using. I'm basically also making use of the final dot, the first 4 columns. So let's run this too. Okay, so once we are done with this, now let's summarize our standardized data. Alright, so you see that with the standardized data, each of the variables is having a mean of 0, right? Mean of 0. If you scroll down, this is also having a mean of 0, mean of 0. In this summary statistics, we don't have the standard deviation, so we can use the apply function to get the standard deviation. So I have this standardized data to SD. So let's see the standard deviation. It should be 1. Yep. So with standardized data set, it always has a mean of 0 and a standard deviation of 1. Now let's look that of the normalized data, the summary. So once we run this, what do we see? Yes, so we have a range of 0 and 1, right? The minimum value is 0, the maximum value is 1, right? The same applies to all the other variables. Minimum is 0, maximum is 1, minimum is 0, maximum is 1, right? So that's basically the difference, right? Okay, so I think we are good to go. So the next thing is to look at summary statistics for qualitative variables. And in this case, we want to make use of the table function, right? Because it's categorical. Um, we are supposed to make use of the table function so that we can get um, our summary statistics in the form of frequency distribution, right? So let's run this. Alright, so here we go. We have Setosa. It counts the number of Setosa. We have 49. Right. Vesica is 50 and Virginica is also 49. Right. So we are good to go.